In this video, we're going to be looking at a bit of a revision of factorizing, graphing quadratic functions. So we'll go through the three sort of methods you can use to factorize quadratic functions and how they relate to creating different forms for graphing them. So firstly, how do we get from a function that is like quadratic? So quadratic function, so to the highest power of 2, and how we get, so ax squared plus bx plus c. So how do we get from that to, let's say, a form like this, which is often called the intercept form, in which we can see straight away what the x-intercepts are by letting y equal to 0. Now there are two different ways. Firstly, there's a recognition way. So if you have x squared plus 6 minus 5x, then you can see that you have to find, this is typically used when there's the number here is 1, and then you can think about what two numbers multiply to get 6 and then add together to give -5. So what about 3 and 2? These two multiply together to give you 6, and then they add together to give you 5. However, they're not the right numbers, as it doesn't give you -5. Rather, two numbers that do work are -3 and -2, as -3 times -2 still give you +6, however -3 minus 2 gives you -5. So that means there's x minus 3, x minus 2, and then these are equivalent. And this is based around that when this is expanded, you get x squared minus 3x minus 2x. So these are being added together, and these are times together to give you +6, and you can see that they're the same thing. The other way is to use the quadratic formula. So the quadratic formula is very useful. So the quadratic formula. And the quadratic formula tells you what the x-intercepts are, and it can be used for all quadratic functions, so it's very applicable. So you have ax squared plus bx plus c. And with your quadratic form, it's very important to get it in this form, as well as in this order. So if you have 2x plus 3x squared minus 5, to reduce small errors, then I would rearrange this to have 3x squared plus 2x minus 5, so you can see directly what is a, what is b, and then what is c. So you should have done the quadratic formula before, but is it the x, so the x-intercepts, or equivalently the x-intercepts, sorry, the y, the x-intercepts is when y is equal to 0, so when the quadratic is equal to 0. So you let x is equal to -b plus or minus b squared minus 4ac, that's square rooted, over 2a. So if you're going to memorize one formula, definitely memorize this one, as it is extremely useful. So b refers to the number in front of the x, c refers to that number, and then a refers to that number. So what happens when you get a square root of a negative number? So let's say -2. Well, obviously -2 does not exist, so therefore there are no x-intercepts. So graphically that may look something like this. So obviously there are no x-intercepts, or something like this. And that, if you think about the number of solutions and b squared minus 4ac, you should see that this is similar, and this is something called the discriminant, which we'll talk about more later. But both these two methods can help you find the x-intercepts, and therefore you can graph the function. So we'll go here. So we'll have this graph, and then let's say we found that the equation is equal to y equals x minus 3, x plus 2. Well, now we know that there's an x-intercept at -2, 0, and at 3, 0 here. Then the y-intercept, we let x equal 0, and we find that it hits here at 0, -6. So I just let x equal to 0 and worked out that calculation. Now from that, I know it has to look, quadratic functions have to look something like that, or that. So to go through all 3 points, it has to look like this one. Now I don't know where the turning point is. There's two ways you can find the turning point. First, you can differentiate, then let equal to 0. Or for quadratic functions, it's halfway between these 2 points. So halfway between -2 and 3. So it's going to be at this point at x is equal to a half. It's going to be somewhere down here. We'll look at calculating turning points more later. But if we expand this out, we get x squared minus x minus 6. Differentiate that, we get 2x minus 1 is equal to, then we let the different dy dx equal to 0. We find that x is equal to a half. And that, as I said before, is going to be halfway between these 2 points. So here, x is equal to a half. Sub that back in, then we can find the y-intercept. The graph will look something like this. So it has this general shape. Just make sure it does go through that point there, 0, 6. Then it has a turning point at a half. That has to be the lowest point. Then you'll also label the turning point. So it's going to be a half. Sub that back in, and you'll get -3 half minus 3, which gives you -5 on 2, so -2.5. Times that by 5 on 2, and it'll give you -25 on 4. So -25 on 4. And if you are going to draw a quadratic, make sure you label the turning point and then also label the x-intercepts. So the third method of calculating or factorizing the quadratic is completing the square. And completing the square means that you don't have it in the other form, such as you have the original, so ax squared plus bx plus c. So you don't get it in the form like this, but rather you get it in the form of x plus d squared plus, let's say, like e, and there can be a number in front here. So we'll have an example and we'll just show how it works. So if you have y is equal to x squared minus 3x plus 25 on 4, then y is equal to x minus 3 on 2. So you divide it by 2, square it, plus 25 on 4, then you minus whatever the number is in here, so 9 on 4. So it gives you x minus 3 on 2 squared plus 16 on 4, which is equal to x minus 3 on 2 squared plus 4. Now obviously that was very quick and it was just to refresh your memory. However, if you don't actually know how to complete the square, then look it up and look at the different method and understand it. So if you have it in this form, you have x minus 3 on 2 squared plus 4. Well, we don't know what the x-intercepts are. However, we do now know what the turning point is. So if we graph it, so we had y is equal to x minus 3 on 2 squared plus 4. Then this is often called the turning point form. That's because you can see straight away that the turning point is equal to 3 on 2, 4. And that's because in this form, whatever the x value is to make that bracket 0, so in this case 3 on 2, is the x value of the turning point. Now if that's the x value of the turning point, this is just going to equal 0. So obviously this number here will be the y part of the turning point. So we know that it's 3, 2, 4. So that's about 1.2. We know it's about here. So therefore it's 3 on 2, 4. Now we're not sure yet if it goes up like this, if it's a minimum or maximum turning point, or if it goes down. However, we will have to find the x-intercepts. So this form is useful for finding the turning point. However, for graphing, you then do also have to find the x-intercepts, which can sometimes be frustrating. But if you let y equal 0, then you'll get x minus 3 on 2 squared is equal to 4, and you can solve from there. So x minus 3 on 2 is equal to plus or minus 2. That's because you just square rooted both sides. Remember, when you square root 4, that gives you plus or minus 2, as minus 2 squared is equal to 4. And then it's plus or minus 2 plus 3 on 2. So that's effectively plus 1.5. So x is equal to negative 0.5 and positive 4.5. But if you leave it as fractions, it'll be negative a half and then positive 9 on 2. So you get a thing here and here, and you can see that the graph will look something like this, where this point here is 9 on 2, 0. This point here is negative a half, 0.